Hello, good day everyone. Today we shall be looking at Cambridge Further Mathematics A-Level Paper 1 Variance 1 May June 2023. Now let's see the first question. The first question is mathematical induction. Mathematical induction. We are asked to prove the mathematical induction that all positive integer n 2a raised to power n is equal to 2 times 3 raised to power n, 3 raised to power n minus 1, 0, 2, a matrix. Now, the first thing you should consider, now, this is the left hand side, and this is the right hand side. Now, we have three steps, three major steps in proving by induction. The first step, let's see whether this equation is correct for n equal to 1. Let's see whether the left hand side will be equal to the right hand side for n equal to 1. So for n equal to 1, the left hand side, as you can see, is 2a raised to the power n. When you put n to be 1, it becomes 2a. That's the left hand side. And what is our a? Our a is 3101. At the end of the day, it gives us matrix 6, 2, 0, 2. That's it. This is the left hand side. Let's also see the right hand side for n equal to 1. Now the right hand side for n equal to 1, the right hand side is a matrix 2 times 3 raised to the power n, and n is 1. 3 raised to the power n minus 1, 0, 2. So what do we have in this case? We have 6, 3 raised to the power 1 is 3 minus 1, 2, 0, 2. So the left hand side, hence the left hand side is equal to right hand side for n equal to 1. That's the first step in proving mathematical induction. And second step, if n for n equal to 1, the left hand side is equal to the right hand side. Now let's put n to be equal to k. If n is equal, for n equal to 1, the left hand side is equal to the right hand side. For n equal to k, it should be equal there. For n equal to k, it will be 2a raised to the power k equal 2 times 3 raised to the power k, 3 raised to the power k minus 1, 0, 2. If for n equal to 1, the left hand side is equal to the right hand side, for n equal to k, it should be correct, because for n equal to k, is true for all positive integers. We confirm it. You see what I'm saying? For all positive integer of k, it should be true. When you check the question, that was they said. For all positive integer of n, for all positive integer of k, it should be correct. And the last step in mathematical induction is that we now put n to be k plus 1. If for n equal to k is correct, we have to find a way to prove it that is also correct when you increase k by 1. So for n equal to k by k plus 1, the equation will turn to 2a raised to the power k plus 1 equal to 2 times 3 raised to the power k plus 1, 0, 3 raised to the power k plus 1 minus 1. Wherever I see n in the previous question, turn to k plus 1. Now, we have to find a way to show that the left-hand side of this one is the same thing as this. Now, the left-hand side is 2a. The left-hand side is 2a raised to the power k plus 1. Let's see whether the left-hand side will be equal to the right-hand side when n is k plus 1. You know, law of indices. A raised to the power k plus 1 means a raised to the power k multiplied by a raised to the power 1. So, in our previous, when you check the question, look at 2a raised to the power n is equal to this. So, 2a raised to the power k will take the same format. 2a raised to the power k will be 2 times 3 raised to the power k, 3 raised to the power k minus 1, 0, 2, multiplied by a raised to the power 1. What is a? A is 3101. 3101. So let's open the bracket. Multiplication of matrix. First, this first row, we multiply the first column. So this multiplied by 3. I think we're going to have 2 times 3 raised to the power k times 3. 0 multiplied by 1. That's 0. When you add 0 to this, you have the same thing. This same first row multiply the second column. This multiplied by 0, is 0. And 0 multiplied by 1 is also 0. Now, second row, we do this, repeat the same process. 3 raised to the power k minus 1 times 3. That's 3 raised to the power k minus 1 times 3, right? So, 3 raised to the power k and also 2 times 1. Okay, hold on. Let me put the result of the multiplication somewhere so you understand the process. The result of multiplication, let me put it there. Okay, let me put the result there. The first row multiplied by the first column. That's 2 times 3 raised to the power k multiplied by 3. 0 times 1, that's 0, comma. The first row, second column, that's 0 plus 0. Second row, first column, that's 3 times 3 raised to the power k minus 1. And also 2 times 1, that's 2. And the next one, the second row to the second column, that gives 0 plus 2, I guess. At the end of the day, when you apply a law of indices, this one will give us 2 times 3 raised to the power k plus 1. This is 0. This one will give us 3 raised to the power k plus 1. Minus 1 plus 2 is plus 1. Minus 1 plus 2. So from here, oh, okay. For this multiplication, it should be for the whole thing like this. We multiply the whole of them. So the answer should be that will be 3 raised to the power k plus 1 minus 3 plus 2. So at the end of the day, we have 2 times 3 raised to the power k plus 1, 0, 3 raised to the power k plus 1, minus 3 plus 2, that's minus 1, 2. Can you see? This is our left hand side. Can you see is equal to the right hand side? So which means the statement is also correct for n equal to k plus 1, which means it's true for n equal to k plus 1. So by induction, n equal to k is true for all positive integers. That is what we are asked to show. Now the next question, find in terms of n the inverse of a raised to the power n. The inverse, for 2 by 2 matrix, 2 by 2 matrix like this, A, B, C, D, your inverse, the inverse is 1 over determinant, which is AD minus BC multiplied by this one swap. A and D will swap, D comes here, A remain, so C and B will be at sign negative. That's how to find inverse. So now, in terms of n, find the inverse of a raised to the power n. From the previous question, we are given 2a raised to the power n. Look at 2a raised to the power n. So if 2a raised to the power n is that, so which means that a raised to the power n, or manage the space, will be half into bracket 2 times 3 raised to the power n, 3 raised to the power n minus 1, 0, 2. So a raised to the power n, open the bracket by half. So the matrix will now become 3 raised to the power n. This one will become half 3 raised to the power n minus 1. This one becomes 0. Half of 2 is 1. This is the matrix. Now this is the inverse we are looking for. So what is the determinant of this inverse? The determinant of a raised to the power n. So 1 times 3 raised to the power n is 3 raised to the power n minus this one times 0. That's 0. At the end of the day, the determinant gives us 3 raised to the power n. That's our determinant, 3 raised to the power n. Let me separate it. So hence the inverse will be 1 over determinant. Determinant is 1 over 3 raised to the power n. This will swap. So 1 comes there, 3 raised to the power n stay there. This is 0, negative 0 is 0, and negative of this 3 raised to the power n minus 1. So you can leave your answer like this, or you can also leave it like this: 1 over 3 raised to the power n, 1, 3 raised to the power n minus 1, the minus is outside, that will be minus 3 raised to the power n plus 1 divided by 2, 0, 3 raised to the power n, or you can leave your answer in this form. That's it. Number 2 question. Number 2 is cubic equation. Now, x cubed plus 4x squared plus 6x plus 1 equals to 0. The roots are alpha, beta, and gamma. We have to find the value of alpha squared plus beta squared plus gamma squared, which is the same thing as what? S2. Now, what's the formula for S2? Okay, so the formula for S2 is summation alpha all square minus 2 summation alpha beta. that formula for S2. So now, how do you find sum of root? The sum of root is minus b over a, and the coefficient of x cubed is a, coefficient of x squared is b, coefficient of x is c, the constant without x is d. So sum of root minus b over a, that's minus 4 over 1, that gives minus 4. Product of two roots at the same time, that's summation alpha beta. So summation alpha beta product of root is c over a, and c is 6, a is 1, is equal to 6. So our S2, which is the same thing as alpha squared plus beta squared plus gamma squared, will be minus 4 all squared minus 2 times 6. Minus 4 squared is 16, 2 times 6 is 12. That gives 4. I hope you understand. Any question is welcome on the comment section. So, question B. Question B said use standard result. Use standard result from the list of formula MF19 to show that summation alpha plus r squared plus beta plus r squared plus gamma plus r squared equal to n into bracket n into bracket n squared plus an plus. Okay, now what we should do here is just don't think too complex, just do your normal expansion. So from here, this is the first one, the second one, the third one. Let's expand them one after the other. Let me start from here. So summation r to 1 n. When you expand alpha plus r, it's just like saying alpha plus r multiplied by alpha plus r is going to give us alpha squared plus 2 alpha r. I get, yeah. So plus, okay, when you expand it, it's going to give us alpha squared plus 2 alpha r plus r squared. So the same thing with the other one, beta plus r, beta squared plus 2 beta r plus r squared. The same thing with the third one, gamma squared plus 2 gamma r plus r squared. That's the whole idea. Now, after expanding it, let's rearrange it, as in the arrangement like collecting the like stem. Summation r to 1 to n. Let's collect the like stem. Alpha squared plus beta squared plus gamma squared. I've collected the like stems of that one. And the other one that look alike there again is 2 alpha r, 2 alpha r, 2 beta r, 2 beta r, 2 gamma r. The 2 is common there, and also r is common there. So that's 2r. So you can have alpha plus beta plus gamma. So, and the last one is r squared, r squared, r squared. That gives us 3r squared. I think I've simplified that. So now, from here, so this one look like S2, summation of square. This one look like S1, that's summation of the 3 roots. So, okay, do you know what I'll do now from what I'm looking at? Let me apply the summation. Okay, let me check the space. Oh, I have enough space. Can you imagine? So let me put the summation to individual. Summation R equal to 1n alpha square plus beta square plus gamma square. Now, this place I can put it like this: 2 rearrange it. I can rearrange it like this. I can say 2 alpha plus beta plus gamma because I know this from the beginning, but I don't know how. Let me put the summation with r equal to 1 to n, and this is plus 3 because the summation only involves r. So r square r equal to 1 to n. So from here, what is alpha square plus beta square plus gamma square? They asked us the question in the first one. So from the previous question, we have alpha square plus beta square plus gamma square is 4. Can you see it? It's 4. So from there we have, this is 4. Alpha square plus beta square plus gamma square is 4. And we have summation up to n. So we say 4n plus 2 alpha plus beta plus gamma. That's sum of root. It gives us minus 4 here. So multiply by minus 4. And what is summation R from your MF19? Summation R from your MF19 will give us half n into bracket n plus 1. Half n into bracket n plus 1 from MF19. So plus, this is 3. What's summation R squared from MF19? That's 1 over 6n into bracket n plus 1 bracket 2n plus 1. If you check your MF19, these are constant. Summation R squared, summation R. So from here, let me simplify. 4n, these two cancel 2. So I have minus 4n times n minus 4n squared minus 4n. I'll open the bracket. Now plus, if you open the bracket by 3, you have half n, because 3 here 1, 3 here 2. So I have half n into bracket. Open the bracket, n plus 1, 2n plus 1. You're going to give us, I think, 2n squared plus n plus 2n plus 1. So from there we have 4n minus 4n squared minus 4n squared minus 4n plus, open the bracket by half n. So it will give us, when you open the bracket by half n, or let's do like this, half n into bracket 2n squared plus 3n plus 1. Yeah, so 4n cancel 4n. So all you have here, minus 4n squared minus 4n squared. So minus 4n squared. So this, so minus 4n squared plus half n times 2n squared, that's n cubed. Half n times, that's 3n squared over 2 plus half n. So collect the like term. When you collect the like term, minus 4n squared plus 3n squared, that will be minus 8n squared plus 3n squared. That's minus 5. It gives us minus 5n squared over 2 plus n cubed plus half n. So n is common. So when you bring the n out, we have n into bracket n squared plus 5 n square, sorry, n into bracket, then you bring n out, n into bracket, n square minus 5 over 2n plus half. Now, let's compare it to what they asked us to prove. They said is equal to, if you remember, they said this expansion, we've expanded this. They said is equal to n into bracket n square, n into bracket n square plus an, n square plus an plus b. So when you equate it, this n is outside the same position, n square the same position, minus 5 over 2n is equal to an. N cancel n. So a is minus 5 over 2 and b is equal to what? Half. I think this is what they asked us to do. Use the standard result to show this. So where a and b are constant to be determined, which we've determined it. Now number 3 question. Use the method of differences to find this summation in terms of n and k, where k is a positive integer. Okay, from here, you need to resolve the expression using partial fraction. How do you do that? 1 over kr plus 1 multiplied by kr minus k plus 1 into partial fraction will be a over kr plus 1 plus b over kr minus k plus 1. So now the LCM here, the LCM is kr plus 1 multiplied by kr minus k plus 1. So at the end of the day, you're going to have a multiplied by kr minus k plus 1 plus b into bracket kr plus 1. They are equal to 1 over kr plus 1 kr minus k plus 1. So this cancel out this. At the end of the day, we have 1 is a into bracket kr minus k plus 1 plus b into bracket kr plus 1. So let's find the value of a and b. Now to find one of them, in partial fraction, equate one of the one in bracket to 0. So let's equate one of them to 0. Equating kr minus k plus 1 equals 0. Let's use amalgamation. Let's just not waste our time. From here, kr plus 1 can be equal to k. Let's do that. So 1 equal to, we've equated this to 0. And kr plus 1 is now k, leaving b to be 1 over k. Also, equate the other one to 0, kr plus 1. Let's equate it to 0. If kr plus 1 is 0, if kr plus 1 is 0, then 1 will equal to a. Kr plus 1 is 0. So we have 0 minus k here, plus kr plus 1 is 0. At the end of the day, we have 1 equal to minus ak. So here, a is minus 1 over k. So after resolving this into partial fraction, we have a and k. Hence, summation of r equal to 1 to n, 1 over kr plus 1, kr minus k plus 1 will equal to What's our A? Our A is minus 1 over K into bracket KR plus 1 plus, what's our B? 1 over K into bracket KR minus K plus 1. So from here, we have the summation. The summation is from R equal to 1 to N. Okay, so let's apply the summation method of differences. 1 over K is common when you bring it up. So what will be in the bracket will be 1 over KR minus K plus 1 minus 1 over KR plus 1. Now you have to do from R equal to 1, R equal to 2, R equal to 3, blah blah blah, up to R equal to N. When R is 1, 1 over K is still outside. When R is equal to 1, K minus K is 0, here will be 1. When R is equal to 1, here will be 1 over K plus 1. When R is 2, we have 1 over 2K minus K, this K plus 1. When R is 2, here is 2K plus 1. When R is 3, this is R equal to 1, this is 2. When R is 3, that will be 1 over 3K minus K, 2K plus 1, minus when R is 3, is 3K plus 1. To be going like that until R is N. When R is N, we have Kn minus K plus 1 all over 1 over Kn plus 1. Let's see when R is N. This is it. Let's see the trend for me to know what to do. Now, minus K plus 1, cancel minus K plus 1. Minus 2K plus 1, cancel this. So definitely this will cancel whatever that is there. And whatever that is there will cancel whatever that is there. So it makes our work easier. So I don't need to get the previous term before N10. So at the end of the day, what is left in this question, in this stuff, is 1 over K is still outside, into bracket 1 minus 1 over Kn plus 1. I think that would be our answer. They said we should use the method of differences to find in terms of N and K, where K is positive constant. This is it. That's it. Second one, we have to deduce the value of summation from R equal to 1 to infinity. Remember that this has been broken down to this. So it simply means summation R equal to 1 to infinity, 1 over KR plus 1 bracket KR minus K minus 1 is the same thing as 1 over K bracket 1 minus K n plus 1. Now, so from R equal to 1 to infinity, so it will be equal to 1 over K 1 minus to infinity, n will be infinity plus 1. So all this one will give us infinity. At the end of the day, we have 1 over K. That's it. The last one. Find also summation R equal to n squared of this. Now, this is a bit trickish and straightforward. How do you find the summation of n to n squared? So what I'll do is that I would use the total sum from 1 to n squared of the whole rational function minus the previous sum from 1 to n minus 1. That will be the logic. So which means that summation of r equal to n squared of 1 over kr plus 1 kr minus k plus 1 is the same thing as, like I said, the total sum from 1 to n squared of the whole rational function. That is, that will be summation r equal to 1 to n of 1 over kr kr 1 to n squared kr plus 1 kr minus k plus 1 minus summation r equal to 1 to n minus 1 of the same function 1 over kr plus 1 kr minus k. Sorry, let me write it fairly. Sorry. So the function will be the sum of from 1 to n squared. The sum from 1 to n squared. So that summation r equal to 1 to n squared 1 over kr plus 1 kr minus k plus 1 minus summation r equal to 1 to n minus 1. So 1 over kr plus 1 kr minus k plus 1. And previously, which is the same thing as summation r equal to 1 to n squared. This is the same thing as 1 over k into bracket 1 minus 1 over kn plus 1 on the previous question, minus summation r equal to 1 to n minus 1, the same thing as 1 over k bracket 1 minus 1 over kn plus 1. Now substitute, when n is n squared, that will be 1 over k 1 minus kn squared plus 1 minus, when n is n minus 1, 1 over k bracket 1 minus 1 over k into bracket n minus 1 plus 1. Open the bracket, we have 1 over k, 1 over k 1 over k minus 1 over 1 over k okay, 1 over k into bracket kn squared plus 1 minus 1 over k minus here will be plus 1 over k into bracket, this is k n minus 1 plus 1. So this cancels this. At the end of the day, 1 over k is common. So we have 1 over k. So we have 1 over k bracket 1 over k into bracket n minus 1 plus 1 minus 1 over kn squared plus 1. This is what they asked us. Find the summation of this also in terms of n and k. Is it? Now let's see number 4 question. The matrix M is given by AC square B square A, where A, B, and C are real constants. B is not equal to 0. Show that M does not represent rotation about the origin. So we have to show that M does not represent rotation. Okay. This kind of question, we have a general formula for rotation. For anticlockwise, rotation for anticlockwise is cos theta minus sin theta, sin theta cos theta. This is rotation for anticlockwise. For clockwise, rotation for clockwise, cos theta still remain the same, but sin theta sign changes. This is rotation for clockwise. Now, the question asks us the matrix M is that we should show that does not represent rotation about the origin. Okay, equate the matrix to any, because the question did not specify whether clockwise or anti-clockwise. Either way, you're going to get the same thing. So equate the matrix with the model for either clockwise or anti-clockwise. Let's use clockwise. If you use clockwise, here it's cos theta, here is sin theta, here is minus sin theta, here is cos theta. You see that A is cos theta, B square is sin theta, C square is minus sin theta. A in both cases is cos theta. So if B square is sin theta and C square is what? Minus sin theta, does it mean that in this case sin theta could be minus C square? So which means that B square will equal to minus C square. If B square is minus C square, that's B square plus C square will equal to 0. Remember the condition, A, B, C are real constant. B is not equal to 0. B is not equal to 0. So in this case, B square plus C square is equal to 0. So which means that this is impossible, because the question said that B is not equal to 0, and here B square plus C square equal to 0, and B is not equal to 0, which means this form is impossible, which means that M does not represent rotation. M does not represent rotation about the origin. That's the meaning. So I guess it's clear. Now the second one, find the equation of the invariant line through the origin of transformation xy plane represented by M. Okay, you know what to do for invariant. Okay, we have space. The matrix is A, B square, C square, A multiplied by xy. Xy axis equal to x is x, y is mx. This is how you solve invariance. Now multiply, open the bracket using 2 by 2 multiplication. First column, A times x is ax plus b square y equal to x. And the other one, this is equation 1. The other one, c square x plus ay equal to mx. This is equation 2. Let's divide equation 1. Divide equation 1 by equation 2. Then we have ax plus b square y equal to x. C square x plus ay over mx. X cancel x. So we have ax plus b square y. Like I said, y is mx over c square x plus ay, y is mx, equal to 1 over m. When you cross multiply, c square x plus amx equal to amx plus b square m square x. Now this cancel this. At the end of the day, we have c square x equal to b square m square x. This x cancel this x. So we have b square m square, which is this, equal to c square. So from here, this can be written as bm square, bm square minus c square equal to 0. Difference between two squares, you can have bm minus c, bm plus c equal to 0. From here, bm can be equal to c, and also bm can be equal to minus c. So here, m can be c over b, or m can be minus c over b. The question asks us to find the invariant equation of invariant line. Since, like I said, y equal to mx for invariant from the origin, so y can be equal to m is c over b x, or y can be minus c over bx. This is the invariant line equation. That's it. And the next question, it is given that M represents the sequence of two transformations xy plane given by an enlargement. Center the origin by scale factor O. Given by enlargement, center the origin by scale factor. Okay, the general formula for enlargement is, the general formula is k0 0 0k. So in this case, the scale factor is 5. The enlargement will be 5 0 0 5. That's the enlargement in this case. So by a scale factor of 5, this is the first transformation mentioned. You need to be very careful about the arrangement. The first transformation is always be the second matrix, the one they mentioned, followed by a shear factor. Followed by a shear x-axis. Now, what is the meaning of shear x-axis? Shear x-axis means direction of x. Now, for shear, the matrix for shear in the direction of x is always in this form. The matrix for shear, the direction of x, is 1 0 k1. Now, this is the matrix in the direction of x-axis. But if it's shear, let me put it there, x direction. If it is shear in y direction, it has another format. I'm going to do that next week when I start my topic out. So shear in x direction. So it simply means, logically, shear in x direction means when you have a coordinate xy, the x direction changes, increases by a factor of k. That's the meaning. That will be x plus ky. The y coordinate will remain the same. This is the meaning of shear in x direction. So in this case, followed by shear x-axis with fixed 0 1 mapped to 5 1. Look at what they said. 0 1 mapped to 5 1. When you check the coordinate, the y-axis remains the same, 1 1. So we can easily get the value of k from here. So from here, x is 0 and x is what? 5. Which means from this my small illustration about share, x turned to what? X plus ky. X turned to x. So the result is 5. 5. The initial value is 0. I don't know the k, but the value of y is 1. From here, k is 5. So share in the direction of x, in x direction, now be 1, 0, 5, 1. This is the second matrix mentioned. So if you are going to find the matrix M, the second matrix mentioned is going to be the first one here, 1, 0, 5, 1. The first one will be the second one, 5, 0, that's enlargement, 0, 5. So multiply the two matrices using matrix multiplication. So from here, first row, first column, 1 times 5, 5, 5 times 0 is 5. The same thing with the second column, 1 times 0, 0, 5 times 5, 25. Second row, first column, this is 0 plus 0, this is 0. And this will give 5. This is the matrix. That's it. Matrix M. That's it. Now the second question. The triangle DEF. Triangle DEF in XY plane is transformed by M onto triangle PQR. Is transformed by M. So the result is triangle PQR. The result is triangle PQR. How do we get triangle PQR? When M is DEF is transformed by M, it gives us PQR, DEF. So this one will be the area of triangle PQR, area of triangle DQR. So given that the area of DEF is 12, now DEF is 12, find PQR. So we need to find the determinant of M. Remember that M is 5, 0, 25, 5. So the determinant of M is 25 minus 0. So the determinant of M is 25. So the area of triangle PQR, the determinant of M is 25. The area of DEF is 12. That gives 300 centimeters square. That's it. If you have any question, put it in the comment section. And the next one is polar coordinate. So number 5, we are asked to sketch the graph of the polar equation r squared equal 1 over theta squared plus 1, and theta is between 0 and pi, and you are asked to state the polar coordinate of the point of C furthest from the pole. First, let's draw the table. The theta is between 0 and pi. So we have theta. We also have our radius. We have theta and radius. R squared. Our theta is 0, 30, which is pi over 6, 9, 30, 60, which is pi over 3, 90, pi over 2, 120, 2 pi over 3, 150, 5 pi. I think this space won't be enough. I want to use the other parts to sketch the graph. Let me do okay, it should be enough. Let's do it. Now theta is 0, 30. 30 is pi over 6. 60 is pi over 3. 90 is pi over 2. 120 is 2 pi over 3. 150, 5 pi over 6. And 180 pi. Okay, what's the radius? Okay, this is a table. When it's 0, the radius will be 1 if you put it there. When it's pi over 6, the radius will be 0.785. When it's pi over 3, the radius is 0.477. When it's pi over 2, the radius is 0.288. When it's 2 pi over 3, the radius is 0.186. Then it's 5 pi over 6 is 0.127. You can find the square root or leave it like that, it's still the same. When it's pi, 0.0920. Now let's sketch the graph. Anyway, there's no way I can show my compass, but you need to make use of your compass to measure your radius. So this is what I need to show you, a rough sketch. Just need to show you a rough sketch of the angle first. My first angle, it starts from here, theta is 0, is increasing. This is pi over 2, and this will be pi. So in between is pi over 4. Before pi over 4 is 30. So this is pi over 3, 30. Pi over 6, sorry, 30. After pi over 6, somewhere here will be 60. That's pi over 3. This pi over 2. Somewhere here will be 120. 2 pi over 3. Somewhere here will be 150. 5 pi over 6, then 180. When you check it, you see that the radius is decreasing. This is where your compass works. Measure your radius using the compass. The first radius maybe is 1. Now this is center at 0. Maybe here is 1. So let me use another colors for point. Okay. And theta is 0, 1. You know the radius will decrease from 1, 0 point something at 30. It's decreasing at 60. You can see it's decreasing. It's decreasing. It's coming down. It's decreasing, decreasing, something like this. The radius is decreasing. So the graph is something like this. That's it. Now, on the question axis to state the furthest, state the polar coordinate and the point of C, furthest from the pole. Furthest from the pole. Okay, the polar coordinate of the point of C, furthest from the pole. Furthest from the pole is, is the initial value anyway. So furthest from the pole is the initial value, r theta. The radius is 1, the first value, theta the point is 0. That's it. This is the graph of r squared equal to 1 over theta squared plus 1. You need to convert it to square root because the equation is in the form of r squared. Let's do it like that. Now the next one, find the area of the region enclosed by C. Enclosed by C, initial line and half line theta. Enclosed by C. What's the initial line? Initial line is when theta is 0. So theta equal to pi. So the area enclosed, you all know the formula for area is half integral r squared the theta. Initial line theta is 0 and theta is pi in this case. So which will be equal to half integral from 0 to pi r squared. R squared is 1 over theta squared plus 1 the theta. So if you check this format, it look like this format. It look like integral of 1 over a squared plus x squared, which is 1 over a arctan of x over a is the MF19. So therefore, we can also use it half. So the integral in this case, this is our x. A is always a constant. So in this case, it will be 1 over 1 arctan. Our x is theta. A is 1 over 1. So we have half arctan theta. Remember that we have theta. Theta can be arctan pi minus half arctan 0. So from here, what do we have? Okay, so this one will give us infinity, undefinable. So this one will give us 0.631. So the answer is 0.631. Now, C question. Show that the point of C furthest from the initial line. Point from C furthest from the initial line. Now, the initial line is the horizontal line. Furthest from the initial line is the vertical line, y-axis. So furthest from initial line is the vertical line, y-axis. So the question shows that the point C furthest from the initial line. So for polar coordinate, you guys know that y is always equal to r sine theta. Since r square equal to 1 over theta square plus 1, so r will be 1 over square root of theta square plus 1. So hence y equal to r sine theta. R is 1 over square root of theta square plus 1 multiplied by sine theta, which is the same thing as y equal to sine theta over square root of theta square plus 1. The questions mentioned furthest from the initial line. The furthest means the maximum. So our maximum point, the y dx is 0. So let's find the y dx. So this is like quotient rule. For quotient rule, we put down the bottom, which is theta squared plus 1. Differentiate the top minus differentiate the top minus put down the top, differentiate the top. Now put down the top, differentiate the bottom. The bottom is theta squared plus 1 raised to the power half all over the bottom theta squared plus 1, the bottom square. So hence the y dx will be like I said, theta squared plus 1 raised to the power half. You don't touch it. When you differentiate sine theta, we have cos theta minus sine theta. Now let's differentiate theta squared plus 1 raised to the power half. It will be half bracket theta squared. Okay, so theta square half bracket sorry, again. Okay, so theta square plus 1 half minus 1, I think it's minus half, multiplied by 2 theta all over the bottom square. In this case, it becomes theta square plus 1. So at the end of the day, we have the y dx will be okay, this 2 cancel this 2. So what left is okay. Remember that maximum point the y dx is 0. At maximum point the y dx is 0. So you equate the differentiation to 0. So theta square plus 1 raised to power half cos theta minus theta sin theta bracket theta square plus 1 raised to power minus half. Everything will not be equal to 0 because the bottom will be equal to, when you cross multiply, disappear. So at the end of the day, we have okay, at the end of the day I have theta square plus 1 raised to power half cos theta equal to theta sin theta multiplied by 1 over square root of theta square plus 1. Meanwhile, don't forget that this is also square root. This one is square root. So I can decide to cross multiply this and this. At the end of the day, I eventually have, when you cross multiply, when both of them multiply each other, I will have theta square plus 1 cos theta equal to theta sin theta. Let me see what they ask us to prove. Cot theta minus 1. Cot should be cos over sine. So divide both sides by cos. I'll have theta square plus 1 equal to theta. No. Divide both sides by sine, not cos. Divide both sides by sine. When I divide both sides by sine, I'm going to have something like this. Dividing both sides by sine, I will have something like this: theta squared plus 1 cos over sine will give us cot theta equal to theta. So now from here, I can divide all through by theta too. If I divide through by theta, then I'll be left with theta squared over theta 1 plus 1 over theta cot theta equal to 1 when I divide both sides by theta. So this is what they asked us to prove. I've shown it. And I said, and verify that this equation has root between 1.1 and 1.2. Now, okay, which means I can now represent this as function of theta to be 1 plus 1 over theta cot theta minus 1. So function, when it's 1.1, put theta as 1.1. So we have 1 plus 1 over 1.1. Make sure you're calculated in radian. Cot 1.1 minus 1. What do we have when it's 1.1? When it's 1.1, we have 0 point, make sure you're calculating in radians, 0.0226. Now also put 1.2. When is 1.2? That will be 1 plus 1 over 1.2 cut 1.2 minus 1. When is 1.2? We have minus 0.209. Now there's change in sign. So since there's change in sign, we have function of 1.1 is greater than 0. Function of 1.2 is less than 0. Sign changes, sign alternates. That's the proof that theta lies between 1.1 and 1.2. That's it. Now number 6. We have 2 more questions, 6 and 7. Okay, vector. So number 6. Now find the equation of the asymptote of C. Equation of the asymptote of C. Now this C, the degree of the numerator is greater than the denominator. So we have to divide. So let's divide x squared plus 2x minus 15 divided by x minus 2 using polynomial. X squared by x, we have 1. 1 times x. 1 times x is x. 1 times minus 2 is minus 2. At the end of the day, x squared plus 2x minus x squared divided by x. So this is x, sorry. X times x, x squared minus 2x. There's nothing there. At the end of the day, this cancelled, this minus. This will give us 4x minus 15. So this is the oblique asymptote. I'm not even done. It's still going. 4x can still go in x. And we have 4. 4 times x, 4x minus 8. This is out. This is 7. Okay. So from here, I have the oblique asymptote. That's y equal to x plus 4. That's the oblique asymptote. And what else again can we deduce the vertical asymptote? Vertical asymptote occur when the denominator is equal to 0. So the vertical asymptote occur at x equal to 2. But the question asks us to find equation of the asymptote. That's it. Oblique asymptote, y equal to x plus 4, and the vertical asymptote, x equal to 2. That's it. The next one, show that C has no stationary point. You know, at stationary point, the y dx will be 0 at stationary point. So let's, and y is x squared plus 2x minus 15 over x minus 2. We're going to use quotient rule, the y dx. Put down the denominator. So, like I said, put down the bottom, differentiate the top. The top is 2x plus 2 minus. Now put down the top. Differentiate the bottom. When you put the bottom, that's 1 all over the bottom square. So the y dx in this case will be the y dx will be, open the bracket, that's 2x squared plus 2x minus 4x minus 4 minus x squared minus 2x plus 15 all over the bottom square. We said if you show that C has no stationary point, at stationary point the y dx will equal to 0. So let's equate this to 0. That will be 2x squared minus x squared. That should give us x squared. Plus 2x minus 2x is out. So we have minus 4x left. Here minus 4x left. So minus 4 plus 15, that's 11 plus 11 all over x minus 2 squared equal to 0. At the end of the day, x squared minus 4x plus 11 equal to 0. We have to show that it has no stationary point. So, which simply means that the equation must not have a root. How do you know it doesn't have a root? Let's confirm the discriminant. B squared minus 4ac. So b is minus 4. 4 squared is 16. A is 1. C is 11. So 16 minus 44 is less than 0. So it has no stationary point. That's it. Now, sketch C, stating the coordinate of the point of intersection with axis. Now, the first, earlier on, we got the oblique asymptote to be y equal to x plus 4. The vertical asymptote, we got it to be x equal to 2. Now, the next one is let's find the point of intersection. The equation is y equal x squared. Y equal x squared plus 2x minus 15. X squared plus 2x minus 15 all over x minus 2. So x-intercept. For x-intercept, y will be 0. When y is 0, let's find the y-intercept when x is 0. When x is 0, what is y? Y will be minus 15 over 2. When x is 0, y is minus 15 over 2. This will give us y-intercept. And also, when x, let's find x-intercept. For x-intercept, this is y-intercept. X is 0. So the other one, so when y is 0, so x-intercept y equal to 0. So we have x squared plus 2x minus 15 equal to 0. At the end of the day, x will be 5 times minus 3 is minus 15. X will be 3 and minus 5. X is 3 or x is minus 5. These are the x-intercept. Y is 0 at that point. So let's plot the graph. Let's plot the graph. Let's plot the graph. Okay, the first one is the maximum value of x. We have negative x, 0, 1, 2, 3, 4, 5, 6 is negative, positive 1, 2, 3, 4, 5, 6. For y-axis, 1, 2, 3, 4, 5, 6, 7, 8. Now the first oblique asymptote, is y equal to x plus 4. Let's find it. Let's plot that graph. When x is 0, y is 4. And when y is 0, x is when x is 0, y is 4. And when y is 0, x is minus 4. X is minus 4 is there. and x is plus 4. This is the graph for that one. And again, vertical asymptote is at x equal to 2. That's the vertical asymptote, is at x equal to 2. We have intercept at minus 15 over 2. We have intercept, is it minus 15 over 2? Let me check it. No, oh, that's plus 15 over 2. Minus cancel minus when x is 0. That's 7.5 somewhere here. Okay. Or let me reduce the scale for this x. Okay. Let's say this is 2, 4, 6, 8, 10. Okay. This is a big asymptote. This is 7.5 somewhere here. We have an intercept on y-axis. We have intercept at 3. We also have intercept at minus 5. We have intercept at minus 5. So how do you sketch the graph? How do you sketch the graph? So which means, okay, most likely if you put values between 2 and 6, if you put value between 2 and 6, it's most likely going to go like this. If you put value between 2 and 6, it's going to go like this. Must pass that 3. And if you put value between minus 5 upward, minus 5, minus 6, like that, it's going to give you something like this. You're going to have a graph to pass through minus 5 and the intercept 15 over 2. So this is a graph. You do have something like this. That's it. Remember, this one still go like this. So this is the graph. Now the next one, sketch the curve with equation. So before sketching, let's write our coordinate of intersection. Is supposed to be a coordinate of intersection. Yeah. So we have 3, 0, minus 5, 0, and we have 0, 15 over 2. Now, this one, you have to sketch the same graph now with modulus. The same graph now with modulus. Here is supposed to be positive. The same graph now with modulus. You know, modulus always take away the negative. So this is what will happen. Let me quickly sketch what I do. Okay, let me use different colors so you can. Of course, you know this, the oblique asymptote. The vertical asymptote. That one occur at 2. Here is 4. Minus 4. Here is 4. Sketch a graph like this. I go like this. And if you remember, we sketch this one past 5 and go like this. Never touch the asymptote. And in this case now, since you are dealing with modulus, so modulus will take away all the negative part. So this will flip upward. for modulus, sorry, like this. For modulus, the negative part here will flip upward. The negative part here will flip upward. So this part ceased to exist. This part. So this part no longer exists. So this is what we have at the end of the day. The one that passed. This is what we have at the end of the day. Don't mind my graph or my drawing. And 6E. Find the set of value for which modulus of 2x squared plus 4x minus 30 over x minus 2 less than 15. Less than 15. So this equation is the same thing as writing 2 into bracket x squared plus 4x minus 15 all over x minus 2 less than 15. So which is also the same thing as saying, for less than 15. So which is, this equation can be written as modulus x squared plus 2x minus 15 over x minus 2 less than 15 over 2. This is 2 after factorizing. Remember this, if modulus x is less than a, it means minus a less than x less than plus a. So the same thing, this thing means minus 15 over 2 less than x squared plus 2x minus 15 over x minus 2 less than 15 over 2. We're going to solve it in two ways. So it could be minus 15 over 2 less than x squared plus 2x minus 15 over x minus 2, or x squared plus 2x minus 15 over x minus 2 less than 15 over 2. So now, so from here, so when you cross multiply, so that will be when you cross multiply, in this case, this comes here, that will be minus 15 bracket x minus 2 less than 2 into bracket x squared plus 2x minus 15. Yeah, so we have minus 15x plus 30, 2x squared plus 4x minus 30. So at the end of the day, so we have 2x squared plus 4x plus 15x minus 30 minus 30 less than 0. So you have 2x squared plus 19x minus 60 less than 0. So which we have 2x squared, 2 factors, minus 5x plus 24x minus 60 less than 0. So from here, x into bracket 2x minus 5 plus is it 12? That's going to be outside that. 12 into brackets 2x minus 5 less than 0. So at the end of the day, So we have x plus 12, 2x minus 5. The least value is minus 12. So the answer take minus 12 less than x less than 5 over 2 for this one. And the other one, the same way, but let's cross multiply. That's 2x squared plus 4x minus 30 less than 15x minus 30. So I think this will go out. We have 2x squared plus 4x minus 15x less than 0. 2x minus 11x less than 0. X into bracket 2x minus 11 less than 0. So yeah, 0 less than x less than 11 over 2. So find the set of inequality of x. This is the set of inequality of x. By now, let me stop here for today. I'll continue in a few hours. I need to rest. It remains just one question. I'll do it in the second part. See you soon.